So in this example, we're going to look at how much it will cost to run a device at a specific rate. So we're given here that we have a laptop with a power of 130 watts. And we're going to run that for 2 hours. Okay, so what are we actually trying to find? Well, the first thing we're going to find is the energy used. And then we're going to find the cost of that energy at the specified rate, which is 18 cents per kilowatt hour. And along the way, we're going to talk a little bit about kilowatt hours and how to move between SI units and kilowatt hours. Standard SI anyways. Kilowatt hours are still using watts and seconds. It's just not as obvious how to convert between the two. Okay. So finding the energy. Well, the energy is 130 joules per second times the amount of time. And we're given 2 hours. But, of course, our watts, our joules per second, need a conversion here. So we'll convert the hours to seconds. So we've got 60 minutes in 1 hour and 60 seconds in 1 minute. Okay, and so we're going to work that through and get an energy of 936,000 joules. Okay, that's great. That's the amount of energy. However, we're not given a cost in terms of joules. We're given a cost in terms of kilowatt hours. So what we're going to need to do is convert the energy to kilowatt hours. So we're going to have our amount of energy in joules, and what we want is some conversion factor. So we'll have 1 kilowatt hour is equal to how many joules, and that'll give us our energy in terms of kilowatt hours. And from there we can get the cost. But how do we get between joules and kilowatt hours? Let's do a little bit of work on the side here and talk about that conversion. So let's talk about joules to kilowatt hours. Okay, so what's 1 kilowatt hour equal to? Well, first of all, we have this kilo, so that's 10 to the 3. So we've got a factor of 10 to the 3 times watt hours. What is a watt hour? Well, let's take a look, and I'm just going to separate this out here. A watt hour is going to be equal to, well, let's say we've got 1 watt in 1 hour, so that's 1 joule per second in 1 hour. So this is an energy. So we'll rewrite this as 1 joule per second to make this really explicit, and we'll write our 1 hour as 3,600 seconds. And so a watt hour is equal to 3,600 joules. So watt hours are a unit of energy, and they are immediately convertible to joules. But notice that it's quite a lot of joules. So we're going to think about, so when we're dealing with consumer devices, and even more so the electricity, the energy consumed by a household, these get to be pretty big numbers. And so we're going to think in terms of kilowatt hours, because kilowatt hours are going to be then a 10 to the 3 times a watt hour, which is 3,600 joules. So a kilowatt hour is equal to 3.6 times 10 to the 6 joules. So it's a pretty sizable unit of energy. And that reflects the amount of energy we're going to be dealing with in these problems. So that's our conversion factor right here, is the 1 kilowatt hour is equal to 3.6 times 10 to the 6 joules. So now we can go back over here to our original problem and say, well, we can convert using this factor, 3.6 times 10 to the 6 joules. And then we end up getting an amount of energy consumed by our laptop in a couple of hours. And that's about 1/4 of a kilowatt hour. All right, now we have the amount of energy that's been consumed by the laptop in units that are easy to manage with this cost. So let's work out the cost. Well, and I'll just denote it with $. Okay, so our cost is going to be 0.26 kilowatt hours times our rate, which is $0.18 per kilowatt hours. And so we get a total cost of about 5 cents. Okay, so it costs about a nickel to run a laptop at this rate for a couple of hours. Maybe it'll be more clear if I just do it this way. Okay, and so that's the cost to run a laptop for a couple of hours. That's it.